Hello guys and gals, and welcome to the first video of Unit 5, Part 2. So, to start off this Part 2 of our notes, we actually need to finish up 5.3 from the other notes. So, in 5.3, really what we're going to be looking at is the fact that half-life can be looked at through a first-order reaction, and it works within our kinetics idea, okay? So, just a reminder, half-life is the time that it takes for half of your sample of radioactive material to decay. So if you have 100 grams of radioactive carbon, how long is it going to take for half of that to decay and leave you with 50 grams? Well, however long it took for it to do that, it will take that same amount of time for you to go from 50 to 25 grams of that carbon, and then from 25 to 12 and a half, and so on and so forth. So, a common radioactive isotope that we see with Chernobyl, that we see with the nuclear bombs, is actually a radioactive iodine isotope. But luckily for us, it decays in its one half-life is about 8 days. So usually it doesn't take too long. In fact, we actually use this in medical treatments. So because its half-life is relatively short, we use it quite often. Even though time is constant in that, so every 8 days, we lose half of our sample of iodine. The amount of particles that decays is always different, right? So the first time we go through a half-life, we lose 50 particles. And then the second time we go through a half-life, we lose 25. And then the next time we go through the half-life, we only lose 12 and a half. And so it's because of that the normal concentration versus time graphs are not linear. But we do find that the natural log versus time graphs for half-life are linear, making it a first-order kinetics problem. And in the fact that we know that it's a first order and it's also dealing with half-life gives us this nice, neat little equation that you will have on your formula sheet, which relates half-life to the rate law constant K. So if you can find K for your radioactive decay, you can solve for half-life, okay? 0.693 is a constant value relating to the half-life. If you really want to see how it's derived, I have some papers that can show you that. You are given this formula. So just understand that if they're asking you to find the half-life of something and you don't really have a lot of information about it, but you do know K, then you can find half-life. Or if you can solve for K, you can solve for half-life. Similarly, if you know half-life, you can solve for K, right? So, don't forget about your units because it is first order. Your K value will always be 1 over time or time to the negative 1. So let's use this to do a quick example together really quickly. So this is a concentration versus time graph, obviously not linear, so we're not dealing with a zero order reactant. This says, what is the half-life of element Q? Well, because we don't have the linear graph, we don't know K, but this graph is going to be pretty nice because it starts at 1. So how long did it take us to go from 1 to 0.5? Well, it took us about 3 minutes. So 1 half-life is 3 minutes. Now that should be consistent though. In order to go from 0.5 to 0.25, it should also take 3 minutes. So let's make sure that that happens. 0.5 to 0.25, and we'll come over here. And yes, it took another 3 minutes to get halfway through it again. So our half-life for Q is 3 minutes. What is the concentration of Q after a second half-life has elapsed? Well, we already kind of answered that to double check our answer above. We went from 1 molar to 0.5 molar. And so our second half-life, we go from 0.5 molar to 0.25 molar. If we were to ask for another half-life after this, we would go from 0.25 molar to 0.125 molar. So, at what time has 75% of the sample decayed? Again, we really just need to look at the graph for this. So let's see. 75% of 1 puts us at 0.25. So the answer is 6 minutes. We already answered this. But we'll look more at how to use T is equal to 0.693 over K and that in these practice problems down here in another video, okay? So that is it for 5.3. We can finally move on to 5.4, and I'll see you in the next video, guys. Let me know if you have any questions.